Good morning children, how are you all? I hope everybody is happy and healthy. So I am very happy to come in front of you after a long time. So I really miss you. So the entire world is fighting with an invisible enemy, that is a coronavirus. So no doubt we will definitely win in this battle, because there is nothing dangerous more than a human being. So even though I request you all to be very careful and follow the advices given by the government and your parents. So come to the point. Today I would like to explain some basic concepts in chemistry. So children, do you know what is chemistry? Chemistry is a branch of science in which we study about matter. That is, what is matter made up of, what is its nature, structure, what changes we observe when it is subjected to different conditions. That is, when a substance is kept in different weather conditions, what changes are going on in particular substance. We all observe those kind of things. Okay, so children, let me explain what is actually the matter. So how can I define the matter in chemistry? So anything in this world which occupies space and has mass is considered as a matter. So children, once again I will repeat the definition of the matter. Anything in this world which occupies space and has mass is considered as a matter. For example, so this piece of chalk is a matter, because when we place this piece of chalk anywhere, it occupies some space and it has mass, so it is a matter. So my body is a matter, because when I stand in here, I am occupying some space and I have mass, so I am a matter. So what not only this, everything, whatever the things around you, they are all considered as a matter. So whether it is solid form, liquid form or gaseous form. So children, why should we learn all about this? What is the purpose of learning about this matter? So let me explain clearly. So if you write the letters on this blackboard, we use a piece of chalk. Can you write with iron? No, it is not possible. So when you get thirsty, you will drink water, not petrol or diesel or any other liquids. And for running the vehicles, we use petrol and diesel, these kind of fuels. So there are different substances we are using in different purposes in our daily life. They are all, you have unique property, and we can easily break this piece of chalk with our fingers. Can you break iron nail? No, it is not possible. What is there actually inside the iron nail to be very strong? Why this piece of chalk is very weak with this? So that we can easily break with our fingers. So children, have you got this kind of doubts in your mind? So there are so many things around you. Observe the nature keenly and try to understand the science behind them. So then your mind will be in the field of science. Okay, so children, matter exists in three forms. You know that matter exists in three forms. You have already learned in the lower classes. So matter exists in three forms: solid, liquid and gaseous. So again, the matter is classified into categories. One is the pure substance, another is the mixtures. So the mixtures. So what are the examples for mixture? Means there are so many things around you that we use in our daily life. The mixtures like milk is one mixture, and wood polish, ice cream, clouds, and oil and water, and sand and water. These are examples for mixtures. Again, mixtures are of two types: the homogeneous and heterogeneous mixtures. So what are the homogeneous mixtures? Example homogeneous mixtures are salt plus water, or sugar plus sugar solution, and these are some homogeneous, these examples for homogeneous mixture. Why? Because in this uniform composition will be there. Whatever the components, actually what are the components? See the mixtures, what are how can I define the mixture? Means mixtures are nothing but they generally they are composed of, they are made up of two or more components. Components are nothing but, for example, salt and water. Salt is a one component, water is a one component, two components there are, so it's a mixture. So and whatever the components are there in the mixtures, we can easily separate with some physical methods like filtration, decantation, distillation and hand picking. There are some physical methods to separate the components which are in the mixtures. So in homogeneous mixtures, the composition will be uniform. Example for salt water and sugar solution. And come to the heterogeneous mixtures. Heterogeneous mixtures are the mixtures which the components never mix together. They are components, the composition of the components are not uniform. For example, oil and water. When you mix soil and water, they want to mix. They never mix. They form layers. And sand and water also. This is also one example. So not only this, there are so many examples are there for heterogeneous examples. Okay. So and children, listen. There are some substances whose components cannot be separated by any physical methods that are used for in the case of mixtures. That substances are nothing but pure substances. So pure substances are nothing but, how can you define the pure substance? Which substance we can call as a pure substance means, for example, if you take a gold biscuit, pure gold biscuit, 24 karat gold. So when you cut any pieces, that you never get any other substance. The composition will be same. Whatever, no doubt, no matter which part you will take for examination. For example, so in pure substance, pure substance are of two types: the elements and compounds. So again, what is the element and what is the compound? Whether it is element or compound, both elements and compounds are made up of molecules. So children, actually, how can we define a pure substance? Means a pure substance is the one which is made up of molecules containing same kind of atoms. So here I am using two important words, the molecule and atom. So children, listen carefully. These two terms are the very important terms in the study of chemistry that try to understand. So what is a molecule actually? So molecule, so let me write the definition of the molecule on the board. Okay children, so the definition of a molecule. So a molecule is defined as the smallest particle of an element or compound that has independent existence and has all the properties of that substance. So nothing but, so actually how a molecule can be defined very simply means, molecule is a very basic and it's a fundamental thing or basic unit of any substance, whether it is solid or liquid or gas. So if you want to know the properties and behavior of any matter, so we should first know what kind of molecules are there in particular substance or matter. So if you know that what kind of molecule, then we can easily know the properties of particular matter. Okay, so and it is a very smallest particle and it has independent existence. Okay, so for example NaCl, sodium chloride. So sodium chloride is it's a compound actually, and it has two different atoms, sodium and chlorine. And another example, for example, H2, hydrogen. Hydrogen is a molecule, and NaCl is also a molecule. So listen carefully, students. These two can be called as a molecule. But here in this H2 hydrogen molecule, these atoms, there are same atoms, similar atoms, and here dissimilar atoms are there. So molecules can be formed by similar atoms of elements or dissimilar atoms of elements. So a molecule which is formed by similar atoms of elements, that is called as an element. So element can be defined as, so it is a substance, it's a pure form of substance in which the atoms are similar element. All the atoms are same elements, same atoms. So that is called as a element. For example, hydrogen is an element, it's a molecule of element. And oxygen gas, it's a molecule of element. And ozone is a molecule of element. And nitrogen gas, it's a molecule of element. And another thing, there is another molecule of compound. So what is a molecule of compound? Compound is one of the pure substance of it's also a pure form of substance in which the atoms, if a molecule is made up of atoms of dissimilar elements, so atoms will be different kinds of atoms, then that pure substance is called as a molecule of compound. Molecule of compound. So now I will write on the board the definition and examples of molecule of compound. Okay children, so we learned that molecule is a very smallest particle of a element or compound, so which has independent existence and that has all the properties of that matter. And a molecule are of two types. So the molecule of element and a molecule of compound. So the example for molecule of element we already learned it. So a hydrogen gas and a nitrogen gas, oxygen gas, ozone and phosphorus, there are some molecules. So these if you observe these molecules, these molecules are made up of same kind of atoms, so similar types of atoms. So and see the molecule of compound. So in molecule of compounds, in these compounds, these are also both are form of pure substance only. But here, if you see the molecule of compound, in this molecule, the atoms are dissimilar. So atoms of elements are different atoms. So if any molecule is made up of by different atoms, dissimilar atom, then that molecule is called as a molecule of compound. Example: water is a molecule of compound; it's a pure form of substance. And NaCl, sodium chloride, and hydrochloric acid and sulfuric acid, H2SO4. These are all example for molecule of compounds. And see, if you see, so the molecule of compounds we cannot see. If you want to try to break down these as a simpler forms, we cannot break this molecule of element. Why? Because they are all completely made up of same kind of atoms. But when we can easily break down into simpler substances as a element. So molecule of compounds can be break down or they break down into simpler substances as elements, and by some chemical reactions or by electrochemical reactions, these compounds, whatever the components are there in these pure substances, we cannot separate by any physical methods that are used for mixtures. Okay children, so we learned about the molecule and types of molecules, molecules of elements and molecules of compounds we have studied. And see the another important definition here, the atomicity. So what is actually the atomicity? The number of atoms that a molecule is made up of is called its atomicity. Means if you, for example, if you take any molecule, whether it is molecule of element or molecule of compound, so we learn that a molecule is made up of two or more atoms. That atoms may be similar or dissimilar. So particular molecule is made with how many atoms the particular molecule is made up of, that is called its atomicity. For example, so molecules can be, see here, molecules can be monoatomic, diatomic and triatomic and tetraatomic and even polyatomic. Then what is actually the monoatomic? Mono means one. So a molecule made up of only one atom in there. So molecule containing only one atom in their elements. The molecule is actually made up of only a single atom, that is called as a monoatomic. And diatomic are molecules nothing but in their molecules the number of atoms will be 2. So that's why it is called diatomic. And triatomic molecules are nothing but these molecules are made up of 3 atoms. So and tetraatomic is nothing but the molecules containing 4 atoms in their elements. And even if the molecule is made up of more than 4 atoms, then that molecule is called as a polyatom. You can call it atomicity, is polyatomicity. And for example, see here, the helium and neon and argon, krypton, xenon and radon, we know that these are noble gas elements. So and these are all in their molecules, that number of atoms will be 1. And there are some metals, their atomicity is also 1, like sodium, potassium and iron, copper and carbon is also. Why? Because these molecules containing a large number of atoms. So that's why these are considered as their atomicity is 1. So monoatomic molecules. So and next come to the examples for diatomic molecules. So oxygen gas, nitrogen gas and hydrogen, chlorine gas, there's a lot of so many things are there. So they are all completely diatomic molecules. Why? Because these molecules are made up of 2 atoms. And O3, ozone, it's an example for triatomic molecule. And P4, phosphorus, it's an example of tetraatomic. And S8, sulfur 8, so it's a polyatomic, or you can call as a octaatomic molecule. So okay students, in 9th class I told you to learn 30 elements from hydrogen to zinc. So they are very important. They are all nothing but elements, and you should compulsory learn their symbols and their serial number. It's not actually serial number, it's called as atomic number. So including atomic number and symbol, element name, you should learn compulsory. If you learn more than 30 also, it's very okay. So total there are 118. Okay students, in the 30 elements there are some name of the elements that are different. For example, sodium. So if you see the name of the sodium, its symbol is Na, and if you see the carbon symbol is a C. So why the sodium is Na and why the carbon is C means, so sodium is nothing but it's a natrium. So natrium, this is a name taken from the Latin language. So from 30 elements there are some elements names. The element names are taken from the Latin languages. That's why their names are different. So the next class, how to write the molecule and how we can write the structure and formula. Okay.